Hello, friends. Today we are going to discuss a topic named simulator, and we are going to see the specific implementation of a simulator called the Test API Simulator. These are the things that we're going to cover in this particular. So, to start with an overview, what is a simulator? Why do you need it? Typical use cases, comparison, and traits, and more importantly, aspects like why we need a certain type of simulator and all that. And in the last implementation, we're going to see the stateful simulator implementation. So to begin with, why do we actually need a simulator? In simple terms, a simulator is a software system that mimics an actual software system. So you can imagine a payment gateway. You can imagine a bank. You can imagine a mobile operator. Any of the services that these folks provide. For example, let's say there's a mobile operator that provides a billing rate. As soon as you make a call and disconnect the call, the amount is being paid from your account, and these all are exposed with the help of some kind of trace API. Or, a simple example, another one is a bank account where someone's account is getting debited and someone else's account is getting credited. So all these are like types of systems in the real world. But now imagine a scenario where you're acting as any type of wallet, right? Paytm, PhonePe, or any other type of wallet that you have. And now they utilize banking services to provide their own services to their own customers, right? But not all the time are these banks or bank APIs that they do available. At the same time, another aspect is like there's a cost involved whenever you call an API from a bank. And let's say you want to certify your product so that things are working fine. Even in their testing environments, they charge you some amount. So to avoid these types of costs and enable certain types of testing, which are not possible with real API integration, simulators come into being. And that's what we're going to discuss. You need it, right? I discuss in brief, like why you need a simulator. Take a typical example, right? If you want to, for example, validate a network timeout, right? Now, in case of a network timeout, you need to hit a certain API endpoint, which will result in an API timeout. By means of API timeout, what I mean is like, let's say if you expect a certain response from some kind of API in 10 milliseconds, and it is not coming right then, you go in timeout, right? But in a real-world scenario, most of the time, when these APIs adhere to certain performance guidelines, then they will return to you with the SLA that you define, which is less than 10 milliseconds for that sake. But at the same time, on the client side, like taking a typical example, again, you are a payment wallet provider, and you want to ensure that debit and credit happen within 10 milliseconds. But I also have to make my system robust and validate that network timeout in such a way that if a network timeout happens, my current state of the system should be in a consistent position. And now, how will you do that right? And that's where the simulator comes in handy, where you will run the request that is incoming right by any means to timeout right, where you will run it for, let's say, beyond 10 milliseconds, say for 1 minute, and you introduce an explicit delay to ensure that this network timeout happens. Another scenario that we're going to cover in the actual implementation can be the case where, let's say, there's a bank customer, and now this bank customer goes, or the account of that bank customer goes, through a cycle where it starts with provisioning, goes to activation, goes to suspension, and is followed by deletion or cancellation. Now, a given user, when we are testing or validating our system as a client, again, a typical payment wallet system, at that point in time, if I want to simulate the scenario to validate that my system, if I am a provider of this type of wallet system, works the way I anticipate in a given scenario where this user goes through a state change. So if I go and do it with the help of bank APIs, it will be too cumbersome because I may not have direct access to those bank APIs that will give me the right data. They will do purging kinds of scenarios where they will remove the data from their system every now and then. So at a given point in time, it will be a long cycle before I can validate that my system is working fine, despite the fact that I coded it. But I can't certify that things are going to work the way I anticipate at a given point in time. And this covers like my two typical use cases, which I want to discuss, where simulators are very important. We're going to see the comparison chart also to validate, like, why this works. Now I move forward, and these are like two types of simulators, which we want to discuss today, stateless and stateful. By any chance, If you feel that you know all these and want to move forward, you can skip this session for, let's say, the first 5 minutes and directly go and jump into the implementation phase, which we're going to discuss at some time. So to start with, there are two types of simulators that we can imagine in the real world, right? One is stateless, and the other is stateful. Okay, take a typical example. Let's say you send a request, and that simulator returns a response. That response comes back, but the simulator does not maintain a copy of that response. So, next time you sign the same request, a simulator creates a new response and sends it back to you. So, in these scenarios, the state is not managed, or the simulator considers every request as a new request. Now, imagine a scenario where, let's say, you want to create a customer on the target application, and then you want to retrieve that customer. So, in that case, retrieval will not happen because the simulator itself is stateless in nature. So, the previous request that was sent is already lost because there is no state maintenance. Right versus a stateful simulator against a typical scenario where a customer is getting created on a target endpoint system, and then you want to retrieve it. This simulator maintains some kind of pointer or a reference to the record that is being written, and then, when you want it back, it gives you the copy that has been created earlier. We discuss, say, the traits, right? So now I go what is your ease of implementation? What is in a stateful and stateless, right? So, of course, if you do not have to maintain a state, you have fewer problems to handle, and it is easy to implement. Similarly, in a stateful, moderate kind of implementation complexity we can think of, but beyond that, it is both stateless and stateful. They have their own niche or requirement in the ecosystem in software development. Applications, typical applications, replies, static output, echo back, input, whatever you send, you come back. You always return the same output irrespective of what request you're sending, right? So, these are the typical applications for stateless versus stateful, different outputs for the same input, right? Again, take a scenario where a customer's account goes through a cycle rate and goes from provisioning to activation to suspension, right? So you send a request for the same customer ID, and then it will return to you once it's provisioned. Then the second time it is active, and the third time it is suspended. So that way, you can simulate various scenarios on your client side, which is consuming the network timeout we discussed before. Part of the functional test. Another important aspect, given the kind of testing each organization performs, it plays a very critical role where you run this functional testing in a cycle every fortnight, every day, or every hour. These tests are run. And you want to ensure that your things are working and we are not introducing any regression, and any new problems or APIs are reaching everything, like a simulator can help you elevate that. Another thing that is not mentioned here that we can talk about is if there are 2 or 3 discrete systems you are communicating with. That's where the simulator can also help. So let's say you have a payment gateway, you have another billing system, and now you are acting as an intermediary. Your payment comes in, and then you post a billed amount as an invoice to the billing system. So, in that case, let's say if the payment gateway is not in your control, you can replace it with a simulator and then post it to your billing system, which is in your control. These are the typical applications that we can put up. During testing, I felt, based on experience, that having limited usage versus stateful not having widespread need, and asking about integration testing, endpoint mocking, and contract-based development. All this can be part of needs schema-generated stateless is easy. I'm saying, with the schema generated, you can generate simulators based on the schema in JSON format or XML format. Sometimes stateful can be generated. There are certain preliminary simulators that are in place. Sometimes they suffice your need, but many times they don't. So, probably at a given point in time, like on the journey of software development, you're going to or bound to create your own simulator or modify the existing simulator. Available in an incremental development cycle. Restart, preserve the state. Another important point. So, if you imagine any endpoint provider, irrespective of when you call it or how you call it, it won't lose the state of the data that you preserve on that particular provider. Again, taking a typical example, once you create a customer on the bank's API, The customer will be there irrespective of whether you retrieve it tomorrow, the day after tomorrow, or not. So here, in the case of a stateful simulator, it preserves the state and depends on what kind of state you maintain. If it is in memory, it will be here till the restart happens. But if it is in the disk or file system or database, then this can persist and retrieve the data even beyond the restarts. Moving next, let's dive deep into the implementation. We covered the basic premise, like why we need it, what the benefits are, the key benefits, and why this makes sense in the real world. Because we're doing everything for a purpose, not just for the sake of learning and forgetting. And that's where I'm coming from, the typical implementation in the real world, instead of just talking about some kind of theory. Coming back to the implementation part, let's say, what is my purpose and motivation? So, probably some of the things we discussed, right? Duplicate requests, network timeout, handling two of the same subsequent requests, right? Sometimes this is very confusing, right? Subsequent, consequent, and all that. So subsequent is like you replay the request one after another with the same, let's say, customer or subscriber, and then you get different responses with all the other scenarios. Recycle, another typical scenario. Take the example of a mobile operator who gives your mobile number to someone else once you stop using it. Let's say 90 days hence or 120 days. A typical recycle scenario. It was against someone named, say, XYZ, and now UVW is using it. So probably these are another typical use case that we need. We have used a template and configuration-driven approach to write a simulator here so that it can be extended. And if you just focus on my first slide, I talk about something called a generic API simulator. And there was a purpose for it because we want to create a simulator that is a baseline and applicable for more than one scenario per SE. There are some prerequisites for the implementation part. I'm using Spring Boot. Though language is irrelevant, I'm using Spring Boot for implementing this generic simulator and conceptual understanding of the services and CRUD operations. CRUD is like create, read, update, and delete, and this further. Users who are coming for the first time. The tool that I am using, Eclipse, Spring Boot Initializer. You can go to the website initializer.spring.io, and then you will get it. Postman. Postman is a REST API client, freely available. You can download it and use it. Maven local installation. Perhaps this is important because we are using Maven as a build system to create our solution. So yeah, without much delay, let's go to the IDE, and here's my implementation part. So I downloaded. Okay, let me put here the typical configuration that I have chosen from the Spring Boot Initializer app. It's like I have chosen Java version 2712 for Spring Boot, and then the default parameters. You can give your name, but I have chosen the default. Packaging type, jar, Java 8, and then the dependencies I want to show you at the bottom. So I have chosen the Spring Boot Starter Web. And then there's Security Lombok, which is for creating avoiding inserting getters and setters in my math-like classes. And then I have Tomcat, probably eventually, if you want to build it as a WAR file and deploy it in some other Tomcat instance. You can do that and then test it. And security. We have not been focusing today on this test and security, but more on the actual implementation. Okay, so probably this is a demo application, which is responsible for creating my simulator app. This comes out of the box from the Spring. I have not done anything here. Once you download the jar or zip folder, you expand it and open it in Eclipse, and then you will see an empty package with a demo application in place. I quickly created 2 to 3 things. One is like a controller. The controller is the first thing that is responsible for intercepting my request, and then responding to the request that is sent by my user. So this is like how a typical post mapping looks. So just before that, what we're trying to do is act as a simulator, like the typical use case. Postman, I will show you what the end state looks like. So I have a bank as one of the entities that I'm integrating with, and it has an entity called user. So here, the simulator is the main primary application context. And then I kept it a simulator so that we understand this is a simulator, not the actual implementation. And then I have 2 things. One is context, which is, say, the main context, which says what domain it belongs to, and then subcontext, the entity of that particular domain. So this is a typical example of a REST API endpoint through which we can avail the services. So here, this service is going to create a user for me. And these are the attributes of a given user, which say that, okay, it has a first name, last name, address, account type, and other things. Similarly, I have created another post request, and this is for a mobile operator here. The domain is mobile, and then there's a subscriber associated with it. It also has the first name, last name, and address. Here, the account type is a Postman instead of savings account. And then there's the area. And we don't need an address for that sake. I'm just assuming that we don't need it. And then we have an ID. This is a client-side ID, which we need to send to the server. And this is another typical example of how integration happens between systems, because you need a way through which, in case of disputes, to identify the payload on the target system, like they're looking for some kind of ID on the client side. Otherwise, it will be very difficult to map like, okay, which request does this belong to? That kind of scenario. So this is the end state. Similarly, this is a stateful simulator. Whatever you create, you can retrieve it with the help of the same subscriber ID and username. Similarly, you have a username and bank account, and you can retrieve them again. So coming back here, this is the post mapping. This looks like context, subcontext. It produces application JSON. And what it actually does is like it forwards this request with the help of context and subcontext. And this way, this is very important because this is generic in nature. You see that we are nowhere mentioning that this is a bank user or a mobile subscriber. So the important aspect of it is that we want the simulator to be generic enough that it can be intercepted and put up in any context that is applicable. So let us say if you have pharma, you have EVs, you have anything, right? So probably you'll have entities, and you are good to go and replicate the simulator on your site. So I have created a simulator service that has an execute method. It takes 4 arguments, context, subcontext, input JSON, that is incoming from the client, and the type of method. Here it is post. So I have passed on the post method. And then in the simulator service, we have an application like call to the application properties, and that's where the templating things come into place. I have just, for the sake of simplicity, used the application. Properties. You are free to use any XML or any JSON outside of this, so you need to pay close attention to this particular part. What we are doing here is we have divided this, or like create a unique identifier for each of the contexts. So here it is, bank. Another context is mobile, and then in the case of the bank, we have divided this into 3 things, and this all comes from the context and subcontext during the lookup. So what we are doing here is like, what are the input fields that are incoming, and then what will be my output template for a given incoming request? So this is like a bank user post, and this is the typical template. Whatever you see in the capitalized letters is the one that is going to be replaced with the actual values. One thing that will come from the simulator is going to be the ID that is going to be generated by the simulator and not by the input request. And that is what will designate that this response is coming with a validation and creation from the service that we are calling instead of just retaining the actual role. So coming back here to the simulator service, what we're doing here is we are taking the input JSON and converting it to JSON. We are retrieving the unique key corresponding to each request that comes in, and a unique key plays an important role. So you have this part. In this particular case, if you see this, you have a subcontext, and context is a unique key. And what that means is that we need to identify that this entity has a unique identification mark if you want to go and look it up on your target system. So what essentially it means is that the unique key for, let us say, for example, a bank is particularly this one, first name, last name, and date of birth, which gives me the unique identifier for this particular record. So if the user name, first name, last name, and date of birth all match, I consider that this is a user whom I can retrieve based on. So the primary key we have created is based on the input parameters. And this is an important concept because all my simulated services will rely on this unique identifier to retrieve the state, which we will preserve during our postcards. So coming back to what we do, first we retrieve the unique key identifier, which means like what all comprises that particular record. So in the case of banks, it is first name, last name, and date of birth, while in the case of mobile subscribers, it is just first name and last name. So each of the contexts will have its own unique key, and that is what we're trying to use. So post that once the unique key is identified, we create the unique identifier key. We are maintaining a map that will store the records that we have seen so far, or the users we have provisioned in that request scene map. And then at the same time, what we're going to do is return the request scene.get key based on. The key is incoming as an input request. So at any point in time, if we see that this user is already provisioned and again this request is coming for reprovisioning or this request is coming for retrieval, we go and see from this map. And this is very important because this request is the one that is maintaining the state for us. Okay. And at that point in time, it returns from here. And in case we want to provision a new one, what we do is, we go to our execute method. And this execute method is doing 2 or 3 things. One is it identifies a context. And what I mean by context is a top-level context, whether it's a bank or mobile. And then, based on that, it finds all the input fields corresponding to that particular context. So, for example, for a post mapping of a mobile subscriber, these are my field identifiers, right? And these are my input fields. So you focus on lines 10 and 11. And these 2 lines together will help us to find or create a response to a given request. And as I move forward, if you see here, I'm just creating the keys and the corresponding part. So what we're doing here again is we're calling one more overridden execute method. And what it does is, it gets the input fields in JSON and then iterates over to get the data corresponding to them. It returns a response, only massaging the output that is coming in from the input, and then uses this to create the response. So probably this is how you can create the state of any particular user that is moving through that particular state. At the same time, you can enable your client applications, for example, the payment gateways or payment wallet applications, to test out the scenarios where a customer's record goes through different states. So in this particular case, it is active, then suspended, and then provisioned. Yeah, so that's pretty much what we have right now. So pretty quickly, I'll just show the demo of this particular thing. And then we say, here we have Harry Potter, and this is for mobile subscriber postpaid. And that's how it looks. I just changed the name to say Raji Potter. And then we said we change the name, as these are the unique identifiers. First name, last name, and date of birth. I changed the name here also in 90. I click on send. This is in the debugger. I continue. Okay, let me mute. You see the output that Rajiv has created, Rajiv Potter. And this is the unique ID corresponding to it. Now, if I use this unique ID to retrieve Rajiv, I should be able to do it with the help of GET. And since I'm using a mobile, I will use the mobile GET request, passing in the subscriber ID. Okay, you see this. Whatever we have posted is being returned, and now the simulator is enabling us to test it out. One thing to note, many newer solutions or simulators are coming out of the box. And if they satisfy your needs, you don't have to reinvent. But it is a good exercise to write down a simulator that will clarify many concepts for you when you're doing the integration with the external APIs. That's a personal experience. But your choice is up to you, how you want to do it. Closing notes, I will go back to the presentation, and this you will find on the Git. I am going to post this all onto the Git repo pretty soon. So these are some of the observations. We are not hard-coding the context in the request mapping. I just want to call out explicitly no context hard-coding. But this simulator is, I think, in nature, you name it, your context will be part of the simulation. Context, when I'm saying context, is a domain. Don't get confused. Context is very, very dynamic in nature. So the request response is managed by configuration. Everything is part of the configuration. Whatever your request, whatever your response, everything becomes part of configuration. Minimal code, maximum usage of the configuration. Design can be adjusted to accommodate any domain. A stateful simulator allows you to mimic real-world scenarios without dependencies and third parties. This is a very important aspect because at any point in time, whenever such complex systems come within a company or within the ecosystem, You may have multiple systems that are integrating with each other, and you may need at one point in time some kind of mimicking behavior. And that's where simulators come in. For future work, you are open to add-ons here, adding support for HTTPS, moving the configuration to XML and JSON, where each request response can be segregated, and expanding the context level. You could deploy more than one instance of a simulator. Now, let's say you want to employ the simulator to do your performance testing, right? Performance testing of the client will be more specific. Then you can create more than one instance. Let's say, if you are limited by the number of requests that the simulator can provide, you can create multiple instances of the simulator deployed behind your API gateway. You can use containers as well. Send your request, get the response, and ask a word or question. Don't use memory-based state management the way this application is using it. You need to outsource or externalize the state management to the database. Or use something like Console, another good remote management-based database, or key value lookup endpoint, and then use it for your stateful needs. Yeah, that's pretty much it for now, and I hope to see you soon. Thank you